Okay guys, sorry, Lepon, this guy, that is me. I had to end that live earlier on because I had a bit of a home situation, so I'm sorry. You sound like my physics teacher. What? Hey man. How can I sound like your physics teacher? Hey man. Me don't sound like a physics teacher. Yes. Okay guys, so I'm going to actually continue on with the factorization, okay? If you don't mind guys, like I said, this is kind of like I'm saying that there's a problem that is going to be potentially a big problem if we don't sort it out. That is a problem amongst the grade 10s, okay, because factorization is forming a very big and huge part of the algebra from grade 10. So if you are a grade 10 student, you are doing maths for the first time, pure maths that is, and you have every intention to stay and do pure maths for grade 11 and 12, then your factorization, your algebra needs to be on point. If it's not, it's going to cause other problems elsewhere, you see. So that is why we need to make sure that the factorization is fine. So as a labor of love and effort towards that, I am going to ensure that we understand the rules and also we can apply. We want to go through some problems and apply, just apply factorization all the time. So just to recap again, I said that there are golden rules that we apply when we are factorizing. The first thing we need to establish whenever we are looking at an expression, an algebraic expression that is, we must first establish how many terms there are. Now, a term is made up of a number. Sometimes attached to the number is a letter, and then the letter sometimes, or let me say the letter always has an exponent, right? That exponent may vary from 1 up until who knows where, okay? So there's a number, there's a letter, there is a exponent. That in turn makes a term, all right? One term, all right? Then a plus and minus sign separates terms, whereas a multiply and a division sign combines terms. Brackets also combine a term, you see. So whenever we are asked to factorize, there are a few things that you need to consider. One, you need to count how many terms there are. Establish how many terms you have. That's the first thing you need to do. Two, you need to then check if the sign change rule needs to be applied in the factorization process that you are engaged in. If the sign change rule, which is a rule that affects terms inside a bracket or terms that have a negative sign in between. Let's say I want the order here inside the bracket to not be y minus x, but to be x minus y. To achieve that, I change the sign outside the bracket. So currently here, this bracket, because it has no sign, we know that the sign that is there, that is invisible, is positive 1. So what we do is we change the sign outside the bracket. If it's positive, we change it to negative. If it's negative, we change it to positive. Then that allows us to change the order of these terms. So this y minus x then becomes x minus y. Okay, so you remember I said here there was a positive, but now look here, outside this bracket there's a negative sign, so the positive sign changed to negative, hence we call the sign change rule. Then the x, which was negative, is now positive and it occupies the first position term. Then the y, which was positive, is now negative and it occupies the second term position. All right, so this is called the sign change rule. And there are times when the sign change rule needs to be applied in our factorization. So after establishing how many terms there are, if we find that the sign change rule must be applied, then we must apply it. But if the sign change rule does not need to be applied, we don't apply it. Please, people, you see. So first count the terms, then check, do I need to apply the sign change rule? If yes, apply it. If not, don't. 3. you must take out what we call the HCF. H means highest, C means common, F means factor. Now, highest, when something is high, it is high, guys. It is the biggest, it is the tallest, it is the hugest, it is the humongous. C, common, when something is common, it is the same. All right, so we check if there is something that is the same throughout all the terms, something that ties the one term to the other. F, factor. A factor, guys, is simply a number that goes into another number without leaving a remainder. All right, so that's a highest common factor, and we identify such according to the sign, which is usually the sign of the first term in our expression that is given to us, number, which is usually the highest common factor between the two numbers, the numbers that are present for the terms that we are given, letter, the letters of the alphabet that are attached to the number. We look at those letters and check if there's a common letter with the lowest exponent. Guys, an exponent is simply this. You see x to the power, this 3 is an exponent, this x is a letter, this 2 is a number, and before this number there's always a sign. If there's no sign before the number, it is an invisible sign which is positive. Okay, but if there is a visible positive sign, then we know that the sign is positive. If it is invisible, it means it's positive, it's just not visible. Are we together? So we take out the sign, number, letter of the which we call the highest common factor of the sign, number, letter of the expression. We take it out, we leave what is left over inside the brackets. Please, guys, we open brackets and we leave what's left over inside the brackets. Okay, yeah. Then we check if inside those brackets is there any other type of factorization that still needs to be done. All right, if it is to be done, we do it. If there isn't, then we stop right there. It means we have done factorizing. If inside those brackets there are like terms that need to be added and subtracted, we add and subtract those like terms. We sort out anything that is within the brackets that basically needs to be simplified, and then we know that we are done. Okay, but remember, guys, other types of factorizations that we've been exposed to are difference of two squares. All right, where we have a difference of two perfect squares, where we open two brackets, one positive, one negative. We take the square root of each individual term and we write the result. Square root of x squared, we have an x and an x. X times x gives us back the x squared. Square root of y squared, we have y, so we put y as well on the other side, and then we put plus and minus, and that's the factorization done. Quadratic trinomial, when we are factorizing a quadratic trinomial, take note that a quadratic trinomial is an expression that has as its highest exponent for the variable a 2. So the x variable has the highest exponent as 2. If a is 1, all right, and our c value is positive, meaning the last term is positive, then we know that that means that our brackets are going to have the same signs according to the sign of b. If the last term is negative, where a is equal to 1, then we know that the brackets will have different signs, and the highest factor will take on the sign of the middle term. Then we have cubic factorization. We know with cubic factorization, we open two brackets, one binomial, another one a trinomial. All right, and if there's a plus sign for our cubic factorization, sum of two cubes, guys, as a rule, if we open those two brackets, if there's a plus sign for the expression, we know that there's a plus sign in between the terms for the first bracket. Then it follows with minus plus. Very simple. If there's a difference of two cubes, all right, then our first bracket will have a negative sign. Then will be followed by plus plus as a matter of rule. Cube root of a cubed, a. Cube root of b cubed, b. Then we say a times what gives you a cubed, a squared. A times what gives you a cubed, a squared. Last term, b times what gives you b cubed, b squared. All right, you check the number, the letter as well. If there's a number as well, that is a perfect cube. Then to get this middle term, guys, you multiply this and that together to get the middle term. It's as simple as that. So that's how you are able to cubic factorize. There's grouping factorization and there's advanced trinomial factorization, where A is not 1, where we basically use the AC rule or any other type of factorization that we may have learned at school that is accessible. Okay, all right, so yeah, right. So earlier on when I was live, just a few minutes or hours so ago, I looked at the factorization of these three terms. All right, so what we did is we followed the rules. How many terms do we have in the expression? We counted how many terms. 1 plus sign, 2 plus sign, 3. So we established that there are 3 terms. Then next question, is there a need to apply the sign change rule? Well, in this situation, no sign change rule needed to be applied. Step number 3, do we have a highest common factor? Because if we do, what do? We take it out. According to what? The sign, the number, the letter. So highest common factor sign is always the sign of the first term. In this expression, the first term is positive, so we take out a positive sign as a highest common factor. Number, highest common factor number, between what? 2, our first term, 8, our second term, and 16, our third term. We are looking at 2, 8, and 16, and we are asking what is the highest common factor. So if you write down the factors of 2, the numbers that go into 2, we have 1, which goes into 2 how many times? 2 times. So these are the factors of 2, 1 and 2. The factors of 8, we have 1 that goes into 8 how many times? 8 times. Followed by who? 2, which goes into 8 how many times? 4 times. And there's no other factor. So this is 1, 2, 4, 8. These are the factors of 8. Factors of 16, 1 goes into 16 how many times? 16 times. Followed by 2. 2 goes into 16 how many times? 8 times. Followed by 3 doesn't go in. 4 goes into 16 how many times? 4 times. And that's it. We don't have any other numbers that go into 16. Then you look at the what, guys? You look at what is common. 2 is common. It is the highest number that is common. 4 is common just for the 2 numbers, not for 2. 8 is common for the 2 numbers, not for 2. 16 is alone. So therefore it means that it's 2 which is the highest common factor for 2, 8, and 16. 2, guys. So we then say that the highest common factor number is 2. So we're going to write 2. Then we move on to the letter. What is the common letter for all the terms that we have that has the lowest exponent? The common letter with the lowest exponent. So you look at your terms. X cubed, x squared, x squared. So x is common, but which one has the lowest exponent? Guys, we can see x squared has the lowest exponent. So we write x squared. Is there another letter that is common for all 3 terms? Well, we don't have any other letter that is common for all 3 terms. Y is alone for the last term. So we do not consider y because it is not a common factor. So we don't write y here at all. So the highest common factor is 2x squared. Now what is left over for each term? Since we took out 2x squared for the first term, what is left over? It is x. 2x squared. Since we took out 2x squared for 8x squared, what is left over? So we check sign, number, letter. Positive times or what gives us a positive? It's a positive. The sign hasn't changed. 2 times what gives you 8? Or what is 8 divided by 2? It is 4. You took out x squared. We need x squared at the end. Do we need any other letter of x next to 4? No, we don't. So we are left with just 4 alone as our middle term. Then we check 2x squared times what gives you 16. So obviously the sign is positive. What is 2 times what is 16? It is 8. What is 16 divided by 2? It's 8. X squared, we are fine with x. We don't need any more x's. Y is a leftover, we write y here as our last term. If we look at the expression inside the bracket, there are no like terms, neither is there any other factorization that can be done. So our answer for factorizing 2x cubed plus 8x squared plus 16x squared y fully is this. 2x squared is the highest common factor, is out. Inside the bracket, x plus 4 plus 8y. So that is how we factorize that expression. Let's move on to this one. How many terms in this expression? We ask ourselves again, how many terms? We can count. 1 plus 2 minus 3, so 3 terms. Next question, is there need to apply the sign change rule? No, because this is not a situation that warrants such a change. Ask the third question, take out the highest common factor. Is there a highest common factor according to the sign number letter? We look at our first term. Our first term has a negative sign, so that means our negative sign, we take out the negative sign as a highest common factor. We then move on to number. Highest common factor number between who? 3, 12, and 6. I don't have to worry about the sign anymore because that's sorted. I'm looking at 3, 12, and 6. All right. Now, because I took out a negative sign, guys, that means all the terms inside the bracket are going to change. This term was negative, the first one, but now it won't be negative, it will be positive. The second term was positive, now it will be negative. The last term was negative, now it will be positive. Okay, because I took out a negative sign. Then 3 times what is 3? It is 1. Okay, so there's a 1 there that you don't see, it's invisible. X, you have 1 x you've taken out. We need 2 at the end. Do we need any more x's? Yes, x times x, another x, will give you x squared. You took out y. Do you need another y to get y? No. So that means x is the only term for the first term. Let's move on to the second term. Negative 3 times what gives you positive 12? Definitely a negative times a negative gives you a positive, and 3 times what gives you 12? 4. 12 divided by 3 is what? 4. X times what gives you x? We don't need any other additions of any variable with x. Y times what gives you y squared? Y times what gives you y squared? You took out 1 y. You need 2 of the y's. How many other y's do you need in order to get the 2 if you took out 1? That means you need an additional y. So that's negative 4y, the middle term. Negative times a what gives you a negative? It's a positive. Then 3 times what gives you 6? Or in other words, what is 6 divided by 3? 2. You took out an x, you need an x. Do you need to add another? No. You took out a y, you need a y. Do you need to add another? No. So that means our last term is positive 2. If you look at these terms, are there any like terms? No. Is there any other factorization that needs to be applied here? This is x minus 4y plus 2. There's no other factorization that needs to be applied. We end that expression right there. Okay. And when we ended the live, I ended the live exactly on this question. So let's look at it just like we have been looking at the other 2 questions. First question that we ask is what? How many terms in the expression? So let's count. How many terms? You tell me in the comment section. The first 3 comments give me the opportunity to move on and ask the next question so that we can actually move and move and move. How many terms in the expression, my beloved people in the comment section? User 1299, thank you so much. There are 3 terms. Letogo Tlengosi, thank you so much. At least, yeah, TikToking the names there. Yes, three terms. I need just one last comment, guys. The best of 3 always help me to be able to confidently move, because if at least 3 people can tell me, you know what they say in the mouth of 2 or 3 witnesses, every word is established. So I just need one more person to let me know how many terms there are. Yes, the black capitalist, thank you so much. Brother Theo, thank you. Lungelo Koza, yes, awesome. So there are 3 terms. Let's see. 2x, remember 2x and x minus 1, the bracket with the 2x means, brackets mean multiply. So this together is 1 term. The plus sign separates, this together is the second term. The plus separates, this together to 12x squared into 1 minus x is the third term. So all in all, we have 3 terms and we've established that. Now, Next question, sign change rule. Do we need to apply the sign change rule? Yes or no? And in which term? So you say yes, and in which term do we need to apply the sign change rule? Is it in the first term, second term, or third term? If you are saying yes. If no, you just say no. We don't need to apply the sign change rule. Look at the brackets and let me know, is there a need to apply the sign change rule? Yes, and where? Theo says last term. User 1299 says 3. I'm guessing you're saying the third term. Letukuta is saying yes. If I take all 3 of your responses, yes, the last term. In other words, the third term. Okay, thank you so much. What a tag team combination answer there at the last term. Yes, the third term. Okay, Letukuta and user 1299 are just fighting the heebie-jeebies there. All right, very good. X minus 1, x minus 1, we are the same. 1 minus x is not the same. Why do we say 1 minus x and x minus 1 are not the same? Just as well as we say 3 minus 1 is not the same thing as 1 minus 3. That's why we say these are not the same. 3 minus 1 is 2, whilst 1 minus 3 is negative 2. We say that subtraction is not commutative. All right. Addition, though, is commutative and multiplication is commutative. In other words, the order in which you place numbers with multiply and subtract and multiply and addition does not matter because the answer is the same. But the order in which you place the numbers with subtraction, it matters because the answer will not be the same. So we say subtraction is not commutative. Ask the grade 8s, they'll tell you about the commutative nature of addition and multiplication and the fact that subtraction is not commutative. Grade 8s and 9s will tell you. So if you're in grade 10, all that basic understanding you learned in earlier grades is useful here. So we say that x minus 1, these are common, but 1 minus x is not common. It's in that moment that because subtraction is not commutative, this needs to change. So we apply the sign change rule for the last term. So what we do is we maintain the first term as it is. We maintain the second term as it is. And then this plus sign magically does what? No, it doesn't magically. There's no magics in maths. It changes. Okay? We take plus and we change it to minus. This is the sign change rule at its best. Negative 12x cubed. That then allows us to swap the order around and say x minus 1. Now what do you see? Bracket same, bracket same, bracket same. We have now common brackets, which is great. Okay. The next question you are going to ask yourself, you've applied the sign change rule. Now the next thing you need to ask is there any highest common factor? And you do what? You take it out. Sign, number, letter, and I'm going to add a fourth letter. Sign, number, letter, B. Highest common factor, sign, number, letter. Now, if you are not someone that I've taught before, my question is to you, if you are someone that I've never taught before, what in the world does the B stand for now? Because surely I've spoken just now about sign, number, letter, but what in the world now is this guy talking about when he's saying highest common factor, sign, number, letter, and then adding the B? What does the B stand for? What am I talking about? Highest common factor sign, we get. Highest common factor number, we get. Yes, the black capitalist, it is highest common brackets. Okay, so here we are talking about the common bracket with the lowest exponent. It has to be common, the bracket, but then it has to have the lowest exponent. Very good. SNLB. Now we are extending our letters to basically accommodate the full breadth and extent of possible scenarios that we may have when taking out the highest common factor. If it is not taking out the sign, not taking out the number and the letter, we are sometimes also going to be taking out the common bracket with the lowest exponent. So the common letter with the lowest exponent is the highest common factor letter. The Highest common factor bracket is the common bracket with the lowest exponent. The bracket must be present for all terms in order to be regarded as a common bracket. Are we together? Hey guys. Hi. Cholo. Yeah, I hope we are together. I hope we're feeling that there, and whilst we are feeling it, bruh, if you're feeling good, if you're feeling great, you can just pretend as if you don't see anything and see me through. So let us look now. Highest common factor, sign. Let's start there. This is positive. This is a positive first term. So since it's a positive first term, it means that the positive sign is taken out as the highest common factor sign. Now let's move to the number. The number means the coefficient before x. We have 2, we have 4, we have 12. So between 2, 4, and 12, what is the highest common factor number? Speak to me. Speak to me. Ooh, ooh. Speak to me. Not next to me, guys. Like, speak to me. Okay? Speak to me about the number next to the x. The highest common factor number is what? Between 2, 4, and 12. Alright? So, Lungelo, yes. I understand you. You've gone to the next extent. So, which means you've identified the letter as well. Highest common factor number between 2, 4, and 12 is 2. Let's move on to the letter. The highest common factor letter between x, x squared, and x cubed. Yes, the x as a letter before the bracket is common, right? Guys, when we are talking about the letter here, we are talking about everything. The number and the letter will always be outside the bracket. We are never talking about the letter inside. No. We are talking about the letter outside the bracket. The number outside the bracket. So 2x is the number and the letter. 4x squared, the number and the letter. Negative 12x cubed, the number and the letter with its sign, as you can see. So what is the highest common factor letter between x, x squared, and x to the power 3? We said the common letter with the lowest exponent. So x is common. We can agree on that, right? But which one has the lowest exponent? So if we write down the letter, which letter are we going to write? Is it x squared? Is it x cubed? Is it x? Which one is it? Highest common factor letter. Lungile, thank you so much. Toby Le7, thank you so much. Theo, thank you. Letoguhle, thank you. Awesome. So basically we have x. Right? So positive 2x is our highest common factor. Now, the last thing, bracket. X minus 1, x minus 1, x minus 1. So, highest common factor bracket is what, guys? What do we write as the highest common factor bracket? Do we have one? Does it exist? Does such exist? Because previously, in both scenarios, we didn't have a highest common factor bracket. Do we have one now? Is there a common bracket that is common for all three terms? What is it? Do we write it down? What is it, guys? Okay. Common bracket. Yes, Letoguhle, thank you so much. Beautiful bracket there, by the way. Yes, and we write it, please, in brackets. So in other words, this is the highest common factor bracket. We put brackets, please, né? 2x positive sign, 2 number, x letter, x minus 1 bracket. So we write it down. This is the highest common factor bracket. Sign, number, letter, bracket. That's common. Then let us check what is left over. So 2 into x minus 1, that is taken out. Now what is left over for my first term? 2x is out, x minus 1 is out. What is left over, guys, for the first term? 2x into x minus 1 times what is equal to 2x into x minus 1? What do I write here for my first term? Let me see what you guys say. What do I write here? If this is my highest common factor and it resonates with my first term, what do I write there? TK says 1. What do other people say? TK is the only one that's saying 1. This is a factorization grade 10. All right, this type of factorization, I tell you now, every grade 8, 9, grade 9, 10, 11, 12, grade 12s grade 12s are the worst when it comes to factorization. Grade 11 sometimes just do funny things as well. Okay, so TK, you are the only one that said if I take out 2x into x minus 1 as a highest common factor for the 1, 2, 3 terms, you are the only one that's saying we are left with the first term of 1. Okay, very good. That's true. If we took out 2x and x minus 1 for 1, 2, 3 terms, it means we are left with what? 1 for our first term. 2x into x minus 1 times 1 will give us back what we have here. Plus, now, 2 times what is 4? That is 2. Okay. X times what is x squared? That is x. We took out the x minus 1 is there, and we need x minus 1 at the end. Do we need to have another x minus 1 here? Definitely not, guys. Definitely not. So that means 2x is the remaining thing for the middle term. Okay. Hello, Purple Holly. Then 2x into x minus 1 times what gives us negative 12x cubed into x minus 1. Remember, 2 times what? A positive times what gives you a negative. So we still have a negative sign. Because remember, we took out a positive sign. So if we took out something that's positive, that means we're still left with the same amount of signs there. Okay, very, very important. So 2 times what gives you 12? Or what is 12 divided by 2? That is 6, right? Okay, very good. Then x times what gives you x cubed? 1x is out. You need 3 of them at the end. How many do you need to add here so that you can x times what gives you x cubed? You have x squared. Remember, guys, when you are multiplying same bases, x and x squared, you keep the variable x as it is. You add the exponents. 1 plus 2 is 3, so it's x squared that you ought to have there. Then remember, you have x minus 1 that is out. You need x minus 1 at the end. So do you need to put anything that has x minus 1 there? Definitely not. Not even close. Okay, so we don't need that. Not at all. Okay. I hope that is cool for everyone. And what we can see here is 1 plus 2x minus 6x squared. Okay. And so in all honesty, when you look at these 3 terms, is there any other type of factorization that can or ought to be done? Okay, any other type of factorization that ought to be done? Okay, no, doesn't seem like it. Okay, so we leave the answer as you see it in the actual question, right? Okay, trinomial can be factorized. Oh, no. Well, go ahead. How in the world will it be factorized? You tell me. This I need to see. How can it be factorized? How? Because the thing is, if you rewrite this, yeah. How can it be factorized? 2x to the power of 2. What are you talking about? 2x to the power of 2. I am waiting for the factorization. I wanted to know how. What do you mean? Okay, so yeah, the expression is left like that. That's basically it. Okay, yeah, that is it. Okay, very important, very key. Okay, very key there. That okay. Hello to you. Hello to you. All right, so let's move on to the next one. That's 3. That's 4. Let's move on to the next. Okay, question says factorize fully 3 into 2a minus 3b into 2a plus 3b minus 2x into 4a squared minus 9b squared. Question says what? Factorize fully. Okay, fully. Factorize fully. All right. So I'm looking at this expression, and the same question is that how many terms do we have in the expression? How many terms? Okay, hopefully you can count the number of terms you see in the expression, and it's very clear the number of terms we have in the expression. Can you see how many terms we have in the expression? Yo, Mohammed. Yo, Nikolai. What the heck? How many terms do we have in the expression, guys? Okay, we have 1, 2. So there's 2 terms in the expression. That's very important. Okay, 2 terms in the expression. Grade 10, you need to know how many terms in the expression. 2 terms in the expression. Second question. Is there a need to apply the sign change rule? Is there a need to apply the sign change rule? Do we need to apply the sign change rule in this situation? Is there a need to apply the sign change rule, guys? Need to apply the sign change rule? Okay, no need. So look at this then. Highest common factor. Okay, we obviously in this case don't, but what we can see as we look at the terms, we're looking at this 2a minus 3b, that's 2a plus 3b. You can see that this is a 2a times 2a and 3b times 3b with a negative and a positive. So this is like the same as 4a squared minus 9b squared. Okay, this and that are the same. So in other words, these are common. Okay, so if I go and say take out the highest common factor, sign, number, letter, bracket, the reality is that if I do this and that, and then I factorize this as well in the same way, have plus and a minus, this is a difference of 2 perfect squares. It will lead me to these very same brackets. Square root of 4 is 2, square root of a squared is a, square root of 9 is 3, square root of b squared is b. So that means I repeat 2a and 3b with a positive and a negative. All right, these are common. These are common brackets, okay, that have been factored. So I'm going to take out my highest common factor sign, which is positive. Highest common factor number between 3 and 2 is 1. Highest common factor letter, we don't have a letter that is common. 3 is here, 2 is here, there's an x, but x is not common, so there's no letter. Bracket, yes, there's 2a minus 3b, as well as 2a plus 3b in combination. So the positive one doesn't even have to show. All I need to do now is take out 2a minus 3b into 2a plus 3b. And listen what is left. So if I have taken this out, what's left on the left hand side? 3. If I take this out on the other side, what is left on the right hand side? Okay, because remember this 2a plus 3b, 2a plus 3b, 2a minus 3b, 2a minus 3b, these are exactly the same. Multiplication of these brackets, the order doesn't matter because multiplication is commutative. 2a minus 3b into 2a plus 3b is the same thing as 2a plus 3b into 2a minus 3b. Okay, multiplication is commutative. The order of the brackets does not matter because with multiplication the answer would be the same. All right, so what's left on the left is 3, but what's left on the right is negative 2x. Negative 2x. All right, yeah, I hope that's clear for us. So that's basically there, factorized. Okay, that is factorized. Okay, any questions? Any real questions that are arising from the floor? All right, yeah, you see, so the thing is, all right, this 4a squared minus 9b squared, if I did not have the insight into factorization of difference of two squares, then I wouldn't have seen the relationship between this two brackets with that bracket. Because for these two terms, the commonality that exists is amongst the brackets. The brackets that are common is 2a minus 3b into 2a plus 3b because it exists in both this term and that term, especially if I have now actually factorized the bracket for the other term. Then you see, oh, this here is actually common. So we take it out, and what is left on the left? It's 3. What is left on the right? It's negative 2x. Okay. Yeah, you see, the thing is, Sunshine BL fan girl, thing is, when you see the combination, when you see factors, when you see factorization, then remember that when you are answering questions, and more especially now if you're writing a test, it's good to be able to see the connections between the different types of expressions and how they then translate into the different factors if we are factorizing. You see, so for instance, 4a squared minus 9b squared, it was easy for me to see, oh, this is a difference of two squares, but the same difference of two squares that I have for this term is the resulting brackets that have been factored, which is 2a minus 3b into 2a plus 3b. It's the same thing. All right, so in my thought process, I first ask how many terms. I established how many terms there are. There's 1, 2 terms. Then this follow-up question was, do I need to apply the sign change rule? No, I don't. Okay, the next question is highest common factor. And when I think about the highest common factor, I think of 3 things: sign, number, letter, but also the common bracket. Don't forget S, N, L, and the B, if there's brackets involved. And the minute I thought of brackets, I was like, okay, I see 2a minus 3b into 2a plus 3b. This is already factored. In my head, I can see the reverse of this being this. All right. Okay. So instead of reversing it back by multiplying it out and applying FOIL so that I get 4a squared minus 9b squared as well on this side, I just thought, let's just go ahead and factor this thing. Because anyways, in my final answer, I need to have an expression that is fully factored. Because remember, we're supposed to factorize fully. So they've already helped me out by factoring this side. I might as well go ahead and factor 4a squared minus 9b squared so that I can see that it's common as per the factors. We take out the common 2 brackets. We are left with 3 on the left. we are left with negative 2x on the right, and that makes life pretty simple and straightforward. Okay, I know some teachers, they are pretty much very strict with the order of the terms in the brackets. Some teachers insist that 2x minus 3, obviously the x term first, the constant term last. Remember, if you are changing the order, what does that mean? It means you've taken out a negative sign. So if you want to take it to that next extent where we're applying the sign change rule to 2x minus 3, remember that negative sign is a negative sign that applies for everything. Okay, so that negative sign is applying for that bracket, so I just take it out so that I can apply the sign change rule, and that is factored completely. I'm sure some teachers would even insist on this as well, all right, where you would actually say 2x into x minus 1. Now remember this, the first term must be the 6x squared, but it's negative. So what you do, you take out the negative sign there, then it changes the sign of every single term. That's going to be minus 2x minus 1. And there it is, you see? So I have that 6x squared is no longer positive. It's no longer negative, it's positive because I've taken out a negative sign for that bracket. The positive 2x is no longer positive, it's negative. The positive 1 is no longer positive, it's negative. That, I would say then, is fully factorized. Fully factorized, and the descending powers, x squared, x constant. You see, x constant, because I know that some teachers insist on writing the expression in descending powers of x within the expression. X squared term, x term, and then the constant term. X term, then the constant term. So we applied the sign change rule just to make sure that we can say we have fully, completely factorized everything. No one can say anything now. They can just keep quiet and enjoy our authentic full factorization without actually even saying a word. Okay, are we happy? Are we pleased? Any questions? Any questions arising? Guys, the process is just nice when you follow the steps, the golden rule. Okay, z, the negative sign. Okay, remember z, if you say negative 3 times 2 times 1, all right, okay, yeah, okay, so me taking out the negative sign for the 3 minus 2x is applying the sign change rule to the 3 minus 2x. So that means I would take out the negative for this bracket. But remember, negative times a positive times a negative, I mean a negative thing times a positive thing times a positive thing is going to completely at the end lead to a negative answer. Just like a negative 3 times 2 times 1. A negative times a positive is a negative. A negative times a positive is still a negative. So the answer is negative 6. At the end of the day, it's going to be a negative whatever. All right, because a positive bracket, a positive times a positive is a positive. But if this is then obviously having a negative sign, it means a positive times a positive is a positive times another negative means a negative answer. Okay, so in the same way here, we took out a negative sign for this bracket, but remember, we are taking out a negative for something that is multiplied to something else. So the positive times a positive times a negative will lead to a negative answer. Okay, please put me in as guest to make myself clear. I think all the people that I guess should just like, if you could, Z, you should send like a huge galaxy there, and just then guest privileges would be nice. What's up? What's the what were you saying basically? Hello?
Hi, how are you?
I'm well, and you?
Yes, I was saying fine, thank you. I was saying the final answer where we now taking out the negative. Is it not going to affect the other factors in the other brackets?
No, it's not. Because as I was saying to you, Z, that the remember,
yes, I understand that part of the. I understand the part of the last bracket. I mean now the first two, the negative now is not
So this is a negative something, this thing. Let's say, for instance, so this is like a negative num or a negative expression. But that negative expression multiplied by something that is positive, multiplied by another thing that is positive, it will lead to a negative something.
Yeah, I understand.
Yeah, but
Okay,
the thing
you
is,
know
the thing
what
is
am I
nothing.
saying?
But for the expressions themselves, 2a minus 3 still remains as 2a minus 3. 2a plus 3b still remains as 2a plus 3b. Okay, that negative that we took out, we took it out for the purpose of applying the sign change rule for this bracket. And then for multiplication, the sign, this is now negative, this is positive, this is still positive. So a positive times a negative is a negative something. That's what I'm saying.
You know what am I saying? Say that you see that the last part where you took out the negative.
Yeah, here.
If we no, the you see the negative that is outside the whole answer.
Which one? This
if
one.
We now
one.
The last step. Yeah,
this
that last step.
Yeah.
Yes. If we now have were to take it back to the previous step.
This one
will still be the same. Yes.
Yeah, it will still lead to the same thing.
Because I'm looking now at the negative now. Is it not affecting the first two brackets?
No. Multiplication is commutative, Z. Remember that if I take this negative, right, and I decide to multiply it with this bracket specifically, a negative times 2x, doesn't it give me back this negative 2x?
Yes, it does.
And then a negative times this positive 2, positive times this negative 3, doesn't it give me back the positive 3?
Yes.
Yes, it does.
We understand each other. But the first two brackets, there where you explaining with the last bracket, we understand each other. I mean now with the first two brackets, is negative not affecting those two brackets?
No. Like the integrity of the expression is still maintained, even though I've decided to put the negative here. I'm just putting the negative here because normally when we write an expression, we write the sign, then followed by the number, the letter, and the brackets.
Okay.
Yeah, so the integrity of the expression will not be affected because I've taken the negative sign and I've put it here. It still retains the integrity of the expression. The answer will still sort of be the same. For instance, I'm going to ask you this. If I say negative 3 times 2 times 1, is there a difference in the answer if I say if I say 3 times negative 2 times 1? Does the answer change because I've changed the position of the negative sign?
No,
hey? So if I decide now I'm going to say 3 times 2 times negative 1, say the negative sign, I'm going to attach it to 1. The question is, does the answer change?
No.
All right. So I still get negative 6 here. I still get negative 6 here. I still get negative 6 here.
Now I get it. All right.
Yeah.
All right. Sure. Thanks.
Sure. Yeah, me wangling, dangling some. Okay. No, I hope that's clear. Clarity is good. Thank you. No, Angel. What no now? What is knowing? Okay. All right. Okay. I think you're answering another question there. All right. Let's move on, guys. More factorization. Okay. Let's look at something else. 2a squared minus 8b squared. Talk to me, guys. 2a squared minus 8b squared. So once again, what are we saying here? Step number 1. First step, what do we say? how many terms in the expression. Okay, so Sunshine, I think you needed Z. Z was able to release many people from their bondage of misunderstanding. Thank you, Z, for coming up and asking your question. It was worthwhile. I see you've released many people from the bondage of whatever. Okay, so once again, question number 1, how many terms in the expression? How many terms in the expression? We start there. Thank you, Sunshine. There are 2 terms in the expression. Question number 2, sign change rule. Do we need to apply the sign change rule, my good people? Is there need to apply sign change rule in this particular expression? No, there's no need to apply the sign change rule. Okay, step number 3, highest common factor. Do we have one? Sign, number, letter, bracket. Sign, number, letter, bracket. Highest common factor, sign. Okay, first term is positive, so we take out a positive sign as the highest common factor. Number 2 and 8, highest common factor, number 2 and 8. Between 2 and 8, what is the highest common factor number? It is 2. Very good. Do we have a highest common factor letter? There's A, there's B squared. Do we have a letter that is common? No, we don't. Do we have a bracket that is common? No, we don't. So we've taken out our highest common factor. It's 2. What's left over? A squared. 2 times what is 2A squared? It's A squared minus 4B squared. All right. 2 into A squared minus 4B squared. Okay, A squared minus 4B squared. Okay. Now, next step. Look inside the brackets. Do we have, check if inside the brackets any other type of factorization can be done. So we have difference of 2 squares, quadratic trinomial, cubic factorization, grouping, advanced trinomial. If you look at the expression inside the bracket, what type of factorization do we have here? Difference minus A squared is a perfect square. Guys, we say when a variable is raised, a variable raised to an even exponent is what we call a perfect square variable. So A is raised to the power 2, B is raised to the power 2. So this term is a perfect square, all of it. The coefficient 1 is also a perfect square. 4 is a perfect square number, all right? So this is literally a difference of 2 perfect squares. And when we are factorizing a difference of 2 perfect squares, we go an arm and a leg and we open 2 brackets. Why? Because we want to put a plus and a minus sign first and foremost. Okay, a negative constant term means a difference, means we are going to have different signs inside the bracket. A negative last term means we are going to have different signs inside the bracket if it's a difference of 2 squares, or if it's a quadratic expression. Okay, thank you so much, Z, for the heart. Me really appreciate it. Much appreciated. Big love to you. Thank you. All right, then we take the square root, guys, of A squared. The what? The square root of A squared. Square root of A squared? A to the power 2, this 2 over 2, the square root, which gives us A. So here we are going to write A and A, because A times A gives us A squared. Then we say the square root of the second term, which is 4. 4, the square root of 4, B squared. Now let's look at the number first. Square root of 4 is 2. Square root of B squared is B to the power 2 over 2, which is B. So we have 2B. The square root of 4B squared is 2B. Very important. So we are going to write here 2B and 2B. Look at the expression. A plus 2B. Can we factorize any further? Any like terms? No. Factorize any further? Any like terms? No. We end right there. We close the chapter right there. Amen. Okay. Amen. Right. Very nice. Very, very nice. Okay, let's look at this guy. 5x to the power 4 minus, say, 125. Okay, so once again, if we look at this particular situation, if we look at this particular situation, yeah, okay, yeah, you forgot that b. Sunshine did forget that b in your factorization initially. Okay, anyways, 5x to the power 4, you're writing in your book. Okay, you're writing 5x to the power 4 minus 125. Okay, so once again, how many terms in the expression? We have 2. Second question, sign change rule needed? No. Third question, is there a highest common factor? Okay. Highest common factor, sign, number, letter. Okay. Sign, positive. Number, 5 and 125. It seems like you guys are writing in the comment section it's 5. So let's take it out. Letter, no. And what are we left with? X to the power 4 minus what? X to the power 4 minus minus 25. Okay, x to the power 4 minus 25. Next step, what do you see inside the bracket? This is the difference. X to the power 4, a variable with an even exponent. This is a perfect square. 25, this is a perfect square. So we have a difference again of what? 2 perfect squares. Okay, so now we can go ahead and open 2 beautiful brackets, which are what? We have a plus sign, minus sign, because the last term is a negative. Okay, then what do we do for what's inside the bracket? We take x to the power 4, the square root of x to the power 4. What is it? X to the power 4 divided by 2, which is x squared. See that? So now we are going to have x squared plus 5, x squared minus 5. The reason we have 5 on the other side, because 5, the square root of 25 is 5. So we're going to have 5, x squared, x squared. Now if you look at this expression, Sum of two squares. Sum of one square, this is not a perfect square. Difference of a square, this is not a perfect square. So we leave the answer like this. Okay, we can't factorize any further. Okay, leave it like this. Okay, happy? Yeah. Oh boy, happy there. Okay. Okay, look at this one. X squared over 9 minus y squared over 16. Okay, x squared over 9 minus y squared over 16. Same questions. How many terms in the expression? Okay, we regard this as 1, the minus sign. Then the second fraction, we regard it as 2. So there are how many terms in the expression? There are 2 terms. Immediately as we say that, sign change rule needed? No. Highest common factor. Okay, highest common factor. Okay, so here we can say 1 is the highest common factor. So we are left inside the bracket with a difference of 2 perfect squares. Now we can say this is a difference of 2 squares. Why? Because x squared, this is a variable raised to an even exponent. 9 in the denominator is a perfect square. Y squared is a perfect square, variable raised to an even exponent. 16 is a perfect square. Okay, so what we can then do here is we can immediately go ahead and open 2 brackets, and then we check what is the square root of x squared. It's x. Square root of 9, it's 3. Square root of y squared is y. Square root of 16 is 4. So what we're going to then have is x over 3 for our first term in each bracket. We then write a plus, we write a minus. Okay, square root of y squared we said is y, and the square root of 16 is 4. So we're going to have y over 4, y over 4. And there it is. Factorized, buddies. Factorized. X over 3 plus y over 4 into y into x over 3 minus y over 4. Okay. Wow, at first I was confused. Now I understand. Well, good for you. Good for you, buddy man. Good for you. Let me go, Karabo Muluzi. Let me go, since I'm a maths late learner. What grade are you in, Karabo? When can we do calculus with derivatives? My goodness. Yeah, some people. 2 into x plus 2 the whole thing squared minus 8. Yeah, 2 into x plus 2 the whole thing squared minus 8. So we look at how many, we look at the first question. How many terms do we have in the expression? Very important to ask that first question. So guys, how many terms do we have in the expression? Let's go. How many terms? 2 terms. Very good. Angel M, thank you. Sunshine, thank you. You guys are saying beautiful things there in the comment section. Nice. Next question. Is there a need for a sign change rule? Now I'm good. Grade 9 traumatized me. Karabo, you are hilarious. Next question. sign change rule needed? No. Highest common factor, sign, number, letter. Highest common factor, sign, number, letter. Very good. Tobile 7. Very nice. Highest common factor. There are two terms, this term and that term. Highest common factor, remember we look at sign. Sign is positive. Number, 2, which is the coefficient, and 8 is what we are looking at. Between 2 and 8, the highest common factor is 2. Very good, guys. Very good. I love what I'm seeing. Letter. Do we have any highest common factor letters? Well, is there a coefficient of x as the is there a variable that is next to the coefficient 2? No. Is there a variable next to 8? No. So that means we don't have a letter that is the highest common factor. We move on. Highest common factor letter bracket? No. So that means 2. We take out 2. Then we are left with x plus 2 the whole thing squared minus 4. Okay, I use square brackets just to differentiate between this bracket and the actual bracket we have taken out 2. Okay. Thank God I chose counting bananas. Oh my goodness. Let's go. All right, then if you look at inside the bracket, guys, okay, is there further factorization that can be done? You see, this is basically the art. When you take out the highest common factor and you look inside, is there a other type of factorization that can be done? And the answer is yes, because you see here inside you have 1. This is a perfect square bracket. All right, so this is a perfect square bracket, and then this 4 is a perfect square number. So this is a difference of 2 perfect squares. So what are we going to do? Well, we're going to do what we know how to do best, and that is open two brackets. So let's do that. Open 1, 2. Then inside those brackets, what do? We are going to write x, the square root. So the square root of x plus 2, the whole thing squared. That means the square root of x plus 2, the whole thing squared, is x plus 2. Okay, square root of x plus 2, the whole thing squared, is x plus 2. Okay, yeah, you apply the square to the square root, and my tendency is to really keep the bracket once after I apply the square root, because we are still working within your bracket. So I write x plus 2. All right, and of course I repeat that x plus 2 this side. Okay, keep the bracket. I am a very good advocate of keeping the bracket. Then of course you know that the first one will be plus, the other one will be negative, and you say the square root of 4. What's the square root of 4? It's 2. Then you write 2 and 2. Very important. Now you think you are done, but the actual reality is that you are not. Now inside each bracket, guys, it's so important to ensure that you do what? You make sure that you simplify what is inside each bracket. So for the first bracket, let us simplify anything if there's any like term. So this x plus 2 that I had brackets in, I'm going to remove the bracket of x plus 2 so that it becomes x plus 2 plus 2. Okay, I distribute the 1 that is a coefficient before this small bracket. 1 times x, x. 1 times 2, that's 2. Okay, and then there's another plus 2. I again distribute the unseen 1 times x, x. 1 times 2, that's plus 2, and then that negative 2 that is there. Don't forget to drop down the 2 that you had taken out as the highest common factor. Final answer is 2. Okay, the x plus 2, 2 minus 2 is 0. You are left with x here. Okay, multiplication is commutative. All right, very important. X plus 2 plus 2 plus 2 plus 2 is 4. So this is x plus 4. Right, this, guys, is the answer of my factorization. Okay, yeah, this 2 minus 2 gives me 0 with the x there. All right, I have an x plus 4 bracket and an x bracket, but remember, guys, multiplication is commutative. The order in which I place this x plus 2 gives me x plus 4. This plus 2 minus 2 gives me 0. I'm left with just an x alone here. So let me just say this, what you see here is x plus 4 into x like this. All right, but then multiplication, this is 2 times the x plus 4 times the x. So it's always nice, guys, the 2, you bring the x next to it, the x plus 4 at the end, because coefficient, numerical coefficient, variable, the bracket. Okay, no, we don't simplify further, guys, because we end right there. We end right here because this is factorization at its simplest form. We can't now go ahead and want to distribute the 2x into the bracket and do all of those things. We leave it like this. This is factored. Okay, very important. This is factored. We leave it like this. 2x into x plus 4. Done, finished, klaar. Okay, klaar, amper klaar. Okay, so I hope this is clear for one and all. Okay, hope this is clear for one and all. Okay, so yes. All right. Okay, I just want to get into some trinomials a little bit. All these people that are telling me to go into algebraic fractions, you must eat your chill pill, my brother. Eat your chill pill and eat it well. Okay, factorize fully. We're still saying factorize fully. Okay, so these are scenarios where a is equal to 1. We can see here in this case our c value is 6 and it is positive. You see, guys, when the c value is positive, then we know that means same signs. Can this person who is spamming calculus please really, like, now you are going to really, I'm busy with grade 10s here. The same calculus you are talking about needs the factorization. So the grade 10s right now, okay, yeah, please can you just stop the spamming with the calculus, because I'm not going to be doing calculus today. So yeah, can you just stop spamming with calculus? I'm not your dog, bruh. I'm not your dog. I think I am not your dog. That I don't think we are on that basis. Okay, so x squared minus 5x plus 6. Okay, x squared minus 5x plus 6, positive sign means same signs. Okay, and it's same signs according to the sign of the middle term. All right, so whenever you have a positive constant and your a is 1, okay, c last term positive means same signs. Same signs according to who? According to the sign of the middle term. So what do we have as our signs? A negative and a negative. I know for sure it's a negative and a negative. Okay, like I repeat, positive constant means same signs. Same signs according to who? The sign of the middle term. So I have a negative and a negative. It's a given. Then I need to find what? The factors of what? Of 6. Okay, twin factors. So 1 goes into 6 how many times? 6 times. So this is 1 pair. 1 and 6. All right, then there's 2 and 3. They are another pair. All right, so I need the pair that when I add the numbers together I will get -5. When I put them together, -1, -6 doesn't give me -5, but -2, -3 does give me -5. The multiplication of which any of these two will give me +6. So I know it's 3 and 2. And then I write x and x, and that's done. Okay, guys, positive constant means same signs. Don't forget that. If you don't forget that, you will always be fine. Let's go x squared plus 6x plus 8. Look at this one again. Positive constant term What does that mean? When a is equal to 1, still same signs. According to who? According to who are the signs the same? According to the sign of the middle term. So when I open my two brackets, what's going to happen? I'm going to have plus plus. Not minus minus this time round, but plus plus, because we are the same according to who? According to the sign of the middle term. So we have plus plus. Guys, positive constant last term means same signs. Get that down. Get that down. Now you're looking for the factors of who? Of 8. So you look for the factors of 8. You're thinking of the factors of 8. When you multiply, you must get 8. When you add, you get 6. So who is working? Is it going to be 1 and 8? When I add these two and they're both positive, I'm getting 9. It's not going to work. Is it 2 and 4? When I'm multiplying these two, I'm getting 8, but when I add, I get 6. It seems like 2 and 4 is the one that's working. Plus 2 plus 4. It's working, that one. 4 and 2, my guys. And then I have x and x. All right, same signs. Positive always means, the last term, positive, means same signs. Always means same signs. Okay? Okay, let's see if you guys can figure this one out. Give me your answer in the comment section, the brackets and all. Boots and all, guys. Factorize this for me. Let's see if you guys are getting the concept. X squared minus 9x plus 18. We're still asking the same question. How many terms? 3 terms. Is there a highest common factor? Well, it's 1 in this case. We're still left with the same trinomial because 1 does not. Yeah, I think, I'm sorry, Z. I think the only reason why that is happening is because I think one of the last few comments, I actually decimated. I think when I just blocked someone now, and I think there was certain things that were blocked together with it. So I'm very sorry about that. Ngateko, no man, you're not following the rule. You're not following the rule, Ngateko. No. Ngateko, be careful. Okay, Ngateko, you are repeating the same error. All right, I said, Moss, when you have a positive constant term, last term, and the a is 1, what do we say? If this is positive, that means same signs. The signs inside the bracket are going to be the same according to who? According to the sign of the middle term. So what does that mean? When I open two brackets, the signs are going to be negative, negative. Positive last term, guys, means same signs. Come on, man. Come on, Ngateko, you're not listening. You're not listening, you're not learning, you're not receiving. And as a result, you're going to continue making those same errors because you're not really paying full attention to what I'm saying. Are you sleepy? Do you want to sleep, Ngateko? Are you Ngatekoing out? Please, Mike, please. Yeah, I don't really. Okay, so same signs according to who? The sign of the middle term. And so, okay, there we go, Sam. There we go. Sam, there you could type. Why is it that you guys can't type, but Sam can? Factors of 18, very good. Very good. So positive constant last term means the signs are going to be the same. If they are going to be the same, they are going to be the same according to the sign of the middle term. So the same. Okay, so what signs am I actually going to be writing here? Whatever this is, those are the same signs I'm writing. Plus means same signs. Whatever this is, those are the signs I'm going to write. Plus means same signs. Whatever this is, those are the same signs I'm going to write. You see, this is what we are doing all the time. So plus means same. same signs. Whatever that is, that's what we are going to write as our signs. Then x squared, you get it by saying x and x, because x times x is x squared. You look for the factors of 18, sorry, not factors of 9, factors of 18. So you have 1 and 18, you have 2 and 9, you have 6 and 3. So Kenzofernal and all the others, you got the factors. There they are. Amen. Hallelujah. 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 Right. Let us continue. Let us continue. Okay. Shalom, bye. Shalom. Peace be unto you as well. Shalom. 3x squared minus 18x plus 24. Look at this trinomial quadratic expression. We have 3x squared minus 18x plus 24, right? So once again, we ask how many terms in the expression. We first figure that one out. There are 3 terms in the expression. Second question, sign change rule needed? No. Third question, highest common factor, sign, number, letter. Okay. Three, 18, 24. Highest common factor sign, positive. Highest common factor number, 3. Letter, no letter. Bracket, no bracket. Then we open a bracket. 3 times what is it? 3x squared. We're left with x squared. 3 times what is 18? We're left with 6x. 3 times what is 24? We are left with 8. Okay. When you took out a positive, no sign change. Okay, not 9x, my guy. 3 times 9 is not 18. 3 times 6 is 18. Careful. Careful now. All right. Then we look inside the bracket. Coefficient of x squared is 1. Sign, the positive constant last term is positive. So that means same sign. Same signs according to who? According to the sign of the middle term here, which is negative. So what do? We don't forget the 3. We open 2 brackets. And thank you so much, Kenzo. Kenzofernal got it down there. Very good. Kenzo is, my life is a joel every day. I can see Kenzo's having a joel writing the correct answers in the comment section. So it's minus, because the negative times the negative is positive. Then of course, same signs according to the sign of the middle term. What 2 numbers? 4 and 2. Factors of 8 will be 4 and 2, not 3 and 2. Can't be 3 and 2. It's 4 and 2. Okay, remember factors of 8. You have 1 and 8. If they are both negative, they're not going to give us negative 6. What about 2 and 4? If they are both negative, they are definitely going to give us negative 6 when we add them. So it's negative 4 and negative 2. Can we factorize any further? No. Okay, so I'm hoping, guys, you are getting it. Positive constant, same signs according to this guy. Negative, negative. Positive constant, same signs according to who? This guy. Positive, positive. Positive constant, same signs according to who? This guy. Negative, negative. Positive constant, negative sign according to who? According to this guy. Negative, negative. You see? So that's what it means when we have a trinomial that is a quadratic expression and it's got a positive constant. Let's see now when we have a negative constant what happens. Let's change it up a little bit here. Okay, let's do one more first. Okay, I can't see this. What is it? Okay, x squared minus 5x minus 84. So this one, how many terms? 3. Sign change rule? No. Highest common factor? Yes, it's 1, but it does not really have an effect on the trinomial. So then we look at the rule attached to factorization of this trinomial, right? So the constant is negative. A is equal to 1. So if A is equal to 1 and C is negative, what does that mean? That means different signs. It means different signs. Okay, for a negative, it means different signs. And it means the biggest factor, or the biggest factor out of your factors of 84 will have the sign of the middle term. Okay, so whatever the sign of the middle term will be, that's basically the sign of the biggest factor out of the factors of 84. Okay, so this is very important. If there's a negative last term, we know that our brackets must have different signs. The biggest factor out of the factors of 84 will have the sign of that middle term. Okay, so what we do is we open the two brackets, different signs. Okay, so the sign of the biggest factor will obviously be negative. Okay, now in the factors of 84 that we have, which one is going to work? Okay, 12 and 7. Okay, I know that because I know my times table, and the 12 and 7, okay, the biggest factor is going to have a negative, whilst the other one is positive. So negative 12 plus 7 gives us negative 5. The multiplication of these two gives us negative 84. Okay, so that means we are going to have x minus 12 and x plus 7. That is basically going to be the factors that we utilize to factorize x squared minus 5x minus 84. Okay, so it works nicely. It works out quite nicely, actually. All right, works out very nicely. Okay, how easy is that with the factorization when the constant is negative? Different signs, guys, just different signs. That's all we are actually ever saying. Okay, thank you so much, Noli. Thank you so much, Noli on wheels. Oh wow, Noli on wheels, thank you so much for the finger heart, really appreciate it. Thank you also for the heart me. Yeah, it's been very quiet, by the way, in this well, as far as that is concerned, so I appreciate it. Thank you so much. Okay, here's another one, x squared plus 4x minus 32. Okay, so once again we have 3 terms. All right, and with these 3 terms, what do we see? Okay, with the 3 terms, sign change rule, there's no need. Highest common factor, it is 1. All right, it is 1, and taking it out does not really have a significant effect than make the 3 terms become 1 because of the bracket and the 1 being outside. So we can then now apply the factorization of a trinomial to the trinomial expression that we have. Wow, Sedi is like setting the tone there, already coming up with the factors. Remember, what does the negative constant last term mean if the value of a is 1? It means we are going to have different signs. Who is going to take on the sign of the middle term? It's the biggest factor of the factors of 32. The biggest factors out of the factors of 32 is going to take on the positive sign. All right, so we are going to have plus and minus, or a negative, positive and a negative. Then factors of 32. I think Sedi helped us out there very nicely. Thank you, Sedi. Sedi, thank you. Danko. Kialeboha. Ki, ya leboga. Danko, danki, thank you, enkosi, siyabonga. Alright, so the biggest factor is going to have a positive sign, whilst the smaller one is going to have a negative. 8 minus 4 does give us 4, makes it nice. 8 times negative 4 does give us negative 32. So that's x and x. We are done. Okay, not too shabby, hey Nige? Not too shabby at all. Yeah, that wasn't too shabby. Okay, please repeat number 2. X squared plus 4x minus 32. If your last term, your constant, is negative, we are saying that means we are going to have different signs inside the bracket when we factorize the trinomial, depending on whether the factors do exist, which when we multiply them give us negative 32, and if we add those factors of 32 give us positive 4. So we are going to have different signs inside the bracket, and we are saying as well that the biggest factor is going to take on, the biggest factor is going to be having the sign of the middle term, which is positive. The biggest factor is going to be positive. So as you can see, the factors of 32 are 8 and 4 that work, whereby when we subtract we get 4. When the biggest factor is 8 and the smallest is negative 4, the multiplication does give us negative 32, and the addition of 8 and negative 4 gives us positive 4, so it works out nicely. Okay, so hopefully you are clear. Okay, so you need to think of factors of 32. There's 32 and 1, which won't work. 16 and 2, which will also not work. 4 and 8, they work perfectly. All right, they are the relevant factors that we would then include here. Okay. Yeah. Can you explain number 1? Are you kidding me? It's the same concept. If the constant is negative, the last term is negative, we are saying the signs are going to be different, but the highest factor always takes on the sign of the middle term. With these ones, we are saying the highest factor takes on the sign of the middle term. So you see 12 and 7, it is the highest factor that is taking on the negative sign. Look at this one. The highest factor is taking on the sign of the middle term. That's why 8 has positive and the other one, the smaller one, has a negative. Okay, so this, like I said, last term, when it is negative, means different signs. You'll remember that when the last term is positive, we said the numbers inside the bracket will have the same signs according to the sign of the middle term. They'll be the same, but here we are saying they'll be different, and the big one takes on the sign of the middle term. Okay, I hope you are getting it, my guy. Hopefully you are getting it. You are not being lost. Can't afford to be lost now. There's no time to be lost now. You need to be found. All right, being lost is not an option. Okay. Look at this one. X squared minus 2x minus 15. Once again, how many terms in the expression? There are 3. Sign change rule needed? No. Highest common factor we need to take out? Yes. What is the highest common factor? Okay, you look at Sid. He said he's so fast with the factors. That's the highest common factor. It's 1. We take it out. Obviously, it just leaves us with x squared plus 4x minus 32 inside the brackets. All right, which moves it from 3, what am I saying? Which moves it from 3 terms to 1 term. Okay, then we open 2 brackets. All right, so remember, last term constant being negative means different signs. So we are going to have a negative and a positive. The highest factor out of the factors of 15 will have a negative sign. Okay, so we have x minus 5 and 3. So that will be x and x. This thing works out so nicely when your times table are here in the head, because the factors, they just pounce out of your head and you see them like literally, and you're like, yeah, those are the factors that will work in this situation. But when your times table is poor, you're going to need your calculator to basically help you search for the factors and quickly get there, right? Remember, these two numbers, when you add, need to give you -2. When you multiply them, need to give you the last term. And the signs need to also agree with that, okay? Just be careful whenever you are busy with this so that we do it accurately and in an appealing fashion. Okay, this one, 3x squared minus 9x minus 12. Once again, how many terms in the expression? How many terms in the expression? There are 3 terms in the expression. So if there are 3 terms in the expression, the next question, do we apply the sign change rule here? No. No need for application of sign change rule. Next question, is there a highest common factor sign? Okay, so we take out the highest common factor sign, which is positive, first term as it is. Number, which is 3. 3, 9, 12. Highest common factor number is 3. Letter, there's no highest common factor letter. Bracket, no highest common factor bracket. So we take out 3. What are we left with? I think Sedi was quick in writing down x squared minus 3x minus 4. All right, yeah, 4 guys, because 3 times 4 is 12. Seems like Sedi changed her answer, I don't know why, and she wrote something completely wrong the next time round. Yes, definitely we'll do that, drop it on YouTube. But yeah, we just have to wait for a while. Then we factorize this, right? Oh, I didn't. Yeah, you were right first time. X squared minus 2x minus 3. That's completely bonkers, bro. Typo. Or yeah, initially you were correct. Okay, now we open 2 brackets. Remember, minus means different signs. Okay, different signs. So minus, positive, and then this middle sign means the biggest factor is going to have a negative sign. Okay, the biggest factor is going to have a negative sign. So the factors of 4, you have 4 and 1, you have 2 and 2. But which one? Okay, 4 and 1, highest factor is going to have a negative sign. Okay, which means the other one is going to be positive. So x minus 4, x plus 1. We can't factorize this any further. We end right there. Okay, guys, different signs. When the last term is negative, you are going to have different sign, but the highest factor is going to take on the sign of the middle term. Please, guys, just really flow in this thing, you know. Finally grab a hold of it and let it make sense. Okay, so guys, I think I've covered sufficient, right? I covered 4 problems where the constant last term was positive, all right, and a is equal to 1, and I said positive constant means same signs according to who? The sign of the middle term. So if this is negative, it means both my brackets are going to be same, negative, negative. Positive constant according to the sign of the middle term, positive, positive. Positive, same signs according to who? The sign of the middle term, negative, negative. Same signs according to who? The sign of the middle term, negative, negative. Do you see that? Please, guys, man. Then the minute your constant changes from positive to negative, it's negative this time around. Negative constant means different signs, okay? But your highest factor of 84 will basically have a negative sign. Okay, that's why you have negative 12 and 7. Okay, remember, you look at the factors of 84. Okay, 4 and 1. How did we get 4 and 1? Remember, we first factorized. We got 3 into x squared minus 4x minus 12. This was the expression that is factorized. You come here, you ask yourself, what are the factors of 4? Okay, so there's 4 and 1, and there's 2 and 2. When you multiply 4 and 1, you get 4. When you multiply 2 and 2, you get 4. But remember, with different signs, we are saying the biggest factor is going to have the negative sign. So we say negative 4 plus 1, negative 4, negative 2 plus 2. So which one works? It's negative 4 plus 1. Why? Because the negative 4 times positive 1 gives us negative 4. But the negative 4 plus 1 gives us a negative 3. So that's how we got 4 and 1. Okay. Please, guys, last term negative means different signs. Last term positive means same signs, but it's the same according to the middle term. Different signs, negative, that is constant, means different signs, but it's different with the highest factor having the sign of the middle term. This is very important, guys. Highest factor has the sign of the middle term. Highest factor, biggest factor will have the sign of the middle term, whilst the other one will have the other sign that's opposite to it. Please, guys, different signs when you have a negative. Okay, different signs, but the biggest factor of 84 will have the sign of the middle term. Let's get that down. Okay, but if this constant is positive, that means same signs according to the sign of the middle term. So that's why it's negative, negative. Same signs according to the sign of the middle, negative, negative. Same signs according to the sign of the middle, positive, positive. Okay, but different signs. Okay, the biggest factor of what? Of 32 will have the sign of the middle term. So the 8 and the 4, the 8 has the positive sign. You see? Yeah. Now, I think to conclude today, let's look at advanced trinomial, just so that now we can get a little bit of exposure. All right. Now, obviously, there are many methods to the advanced trinomial which people use. I know some people use the slide and divide method. I know some people use the AC method. All right. The one that is long, where you multiply your A value with your C value, you get the factors, which when you multiply give you the product of A and C, but when you add them, they give you the coefficient of the middle term in the actual expression. Then you replace that expression that you get, those factors, in the place of the middle term with the variable attached to them. Then you group, factorize, take out common factors from pair of factors, and then you establish common brackets, which then lead you to the product of two factors, the brackets expressions which you need for the trinomial to have been factorized. Okay, so we are going to actually look at this method. Okay, so as I said, this is A, this is C. The answer is negative 36. Now I need factors of negative 36. These factors of negative 36, when I add them, need to give me negative 5. So in my head, I'm thinking of 36 and 1. I'm thinking of 2 and 18. I'm thinking of 3 and 12. I'm thinking of 4 and 9. And it seems like 4 and 9, negative 5, those will work, right? because if we have a negative 36, it means different signs, but the highest factor will have the negative sign. So now we can put x, and we know that the addition gives us negative 5x. So this person here needs to replace this person here needs to, 4x minus 9x needs to replace negative 5x in the original expression. So what we say is 3x squared. In the place of negative 5x, we are going to put 4x minus 9x. Or we can say negative 9x plus 4x. Negative 9x plus 4x minus 12. Then we can proceed and group factorize. All right. Let me repeat this one more time. You take a, you multiply with c. A times negatives, a times c. In other words, 3 times negative 12. 3 times negative 12 gives you negative 36. That is the product of a and c. Right? Not the African National Congress, the party that we vote for. But we are talking about the coefficient of x squared, which is a, and then the constant last term, which is c. You multiply 3 times negative 12, you get negative 36. Then you want to find the factors of what? Of negative 36. When you multiply them, they need to give you negative 36. When you add them, you need to get negative 5, the middle term. All right. So this negative 36 to me says different signs. But you know what? The highest factor will have a negative sign out of these factors. The highest factor will have the negative sign. So negative, positive, negative, positive, negative, positive, negative, positive. Now the addition of the one that gives me negative 5x is what I'm looking for. So hence I'm saying 36 and 1 don't work, 2 and negative 18 don't work, 3 and negative 12 don't work, but 4 and negative 9 work very well. So then what I do is I attach x's to the factors that work to give me negative 5x. I attach x's and then I replace the negative 5x, the middle term, with this expression, which are basically my factors, all right, with x attached to them. I replace this with the factors. So I replaced negative 5x with negative 9x plus 4x, and then obviously the 3x squared was there, the negative 12 was there. Then I'm going to group factorize. So the first two, I group them. The highest common factor that I can see here is 3x. What am I left with? X minus 3. Here for the last two terms, the highest common factor for the last two term is positive 4. I'm left with x minus 3. Now you can see there's a common bracket of x minus 3. So I take out that common bracket of x minus 3. And then I'm left with what on the left? 3x. I'm left with what on the right? Plus 4. I have done factorizing the advanced trinomial. And it is as straightforward and simple as you see it being done. The advanced trinomial is basically finished. This advanced trinomial is a method we apply when a is not 1, all right, and it's very clear that a is not a highest common factor. So therefore that means we are going to have to factorize this thing with a coefficient that is not 1. And when we so do, we do this AC method, a times c, we get the negative 36, and we work on it the way that you have seen me work on. Okay. There are various other methods, but I think this method, right, basically also helps polish your grouping factorization skills. So it's like 2 in 1. It kind of kills 2 birds with 1 stone, and it also helps familiarize you with your grouping factorization and sort of like the skills of making sure that you know how to, because the last portion or part of the method incorporates grouping factorization in the mix. All right. Yeah, I hope that really did not fall on deaf ears. That it received some landing ground so that it can grow, spurt, and develop. Okay. We look at another one, 12 minus 16x minus 3x squared. This one is a typical expression that is not in the regular normal nice standard form. So what I'm going to do is I'm going to first and foremost rearrange this to become negative 3x squared followed by negative 16x plus 12. Then take out the negative highest common factor and get 3x squared plus 16x minus 12. Okay. Then remember, I'm going to say for what's inside the bracket. I couldn't take out the highest common factor here, right? It wasn't going to be feasible, at least highest common factor as far as the number is concerned, I mean. So the A cannot be 1, okay? It cannot be 1. So what I'm going to do is do AC method. I'm gonna take the 3, multiply it by negative 12, still get negative 36. Hey, negative 36 loves us. Okay, big time. Then find the factors. Factors of what? Of 36. When I multiply these factors, okay, they are going to have different signs first and foremost, but the highest factor is going to have the sign of the middle term. So 36, I have 36 and 1, highest factor is going to be positive, then the other one's negative. We have 2 and what? 2 and 18, okay, positive and negative, and it seems like this is the one that's going to work because positive 18 minus 2 gives you 16. So we're going to put x and x there because of the fact that in the middle term we have only x as the variable. If we had xy, we'd put xy as well, and so it goes, so that we can replace appropriately. Plus 18x minus 2x minus 12. Let us continue. Negative. Okay, so here common factor between the two, that is 3x into what? X plus 6 minus 2 is a common factor, x plus 6. Final answer, negative into x plus 6 into 3x minus 2. There it is. Okay, thought it was difficult, but really wasn't. Just straightforward to the point. Yeah, advanced trinomial, advancing, making us big bosses. Okay, all right guys, thank you so much. I hope you really gained a lot from the session. I hope you did. I hope it was a meaty session for you guys. Do I dare end? I guess let's see. And I did 2 advanced trinomials. I think it's only fair to just sort of like venture and see. X cubed minus 64x. How many terms in the expression? 2. Second question, is there a need for a sign change rule? No. Third question, is there a highest common factor? If there is, take it out. Sign, number, letter, bracket. So x cubed and x, it's 1x into x squared minus 64. All right. So highest common factor, take it out. But inside the bracket, what do you observe? Difference of 2 perfect squares. So what do? We open 2 brackets. We put plus and minus. Square root of x squared, we have x and x. Square root of 64, we get 8 and 8. Any further factorization inside the brackets? No. We leave the answer as it is. Okay. 4x squared minus 100x. Once again, how many terms do we have in the expression? 2. Second question, sign change rule needed? No. Third question, is there highest common factor? Yes. Sign, number, letter? Well, first term is positive. We take out a positive sign. Positive. Number 4 and 100, we take out 4, that is positive. X squared and x, we take out x, right? Yeah, and then what are we left with? X minus what? 25. Okay, do we factorize any further? No. Let's be careful, guys, to not take out just a common factor, but we need to take out the highest common factor. It's not correct if you take out a common factor of 2x, because 2x is not the highest common factor. It may be a common factor, that's not the highest. So be careful when such is the case. X squared plus 64. Factorize this. X squared plus 64. Now, thank you so much for the heart me. Wow. Yeah, hey guys, these heart me's and these gifts, they mean a lot when they do come. So thank you so much. I really appreciate it. Very, very scarce such things. So thank you. I appreciate it. I'll even appreciate it more if people can support me in my life goal. That would be great. You know, I do have a goal that you guys learn, but I also have a goal that you guys can rightfully extend a monetary hand if you can. X squared plus 64, guys. X squared plus 64. Factorize fully. Such. Okay, this is the sum of two squares. All right, we cannot factorize this. The only thing we can do here, which is doable, is to just simply leave it like this. X squared plus 64. In other words, we've taken out a highest common factor of 1, and then we've put the x squared plus 64, which initially was 2 terms. We now write it as x squared plus 64, which is 1 term in brackets. It's not x plus 8 into x minus 8. Let's be very careful about that. Okay, look at this one. Negative x squared plus 64. Negative x squared plus 64. So once again, if we look at this one, okay, negative x squared plus 64. All right, negative x squared plus 64. So what we do here, this is an expression, we are supposed to factorize it. Okay, first things first, we ask how many terms. There's 2. Second question, is there need for sign change rule? No. Third question, is there highest common factor? Well, if you look at the first term, it's negative, right? And so obviously a negative sign, if the negative sign is there available in the first term, we take it out. Negative what? Negative 1. What's left inside? X squared minus 64. Whenever you take out a negative sign, then of course you have the signs inside the bracket change. The x squared, which was negative, becomes positive. The positive 64 becomes negative 64. Right, Tobela, that is incorrect what you are saying there in the comment section. 64 becomes negative 64. The other plus minus root of 64. No, my brother. This particular question, not so. Not so, not so, not so. Okay, and remember, this is not an equation, it is an expression. So factorizing it, the sum of 2 squares is simply not something we can factorize any further beyond just taking out a common factor of 1 and writing in brackets x squared plus 64. This one we can definitely. Okay, what you see inside the bracket is a difference of 2 squares. So what do we do? Open 2 brackets. What are the signs inside? Positive and negative. What is the square root of x squared? X and x. What is the square root of 64? 8 and 8. Do we factorize any further in each bracket? No. we are done. Difference of two squares factorization inside the bracket. Okay, preceded by highest common factor factorization, concluded by difference of two squares, and the negative sign you don't leave behind, guys. It sticks like, I don't know, like a partner or a wife that is faithfully loyal to a significant other. Same thing, husband, significantly loyal, attached, like nobody's business and to no one else. Okay, very important, these things. Very, very important. Very, very important. Very, 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 very. Okay, let's look at this one. 125x cubed plus 64. What type of expression is this? Okay, so here we have two terms in the expression. How many terms? 2. 1 plus 2. So 2 terms. Second question, is there a need to apply the sign change rule? No. Third question, is there a highest common factor between 125 and 64? The reality is no, there isn't, except 1, but 1 is not significant. Okay, then we have to then look at this and ask ourselves, okay, 125x cubed plus 64y to the power 6. What type of factorization should we then apply here? Well, this is a sum of 2 cubes. Why do we say it's a sum of 2 cubes? Remember, for a variable, in order for a variable to qualify as a cube, it has to, when we apply the cube root to that specific variable and its exponent, it has to, when applying the cube root, lead to a integer exponent, a positive integer exponent. So for instance, if you apply the cube root to y to the power 6, 6 divided by 3, 3 goes into 6 2 times, so it's y squared, right? Cube root of 64 is 4. Cube root of x cubed is x. Cube root of 125 is 5. So that means we do have the ability to then factorize this. So we open a binomial and a trinomial bracket. This was positive, so that means the first bracket will be positive, and it will be followed by negative, positive, just like that. Okay, negative, positive, negative, positive. All right, hopefully that makes sense. Raising 3 queens, is that raising 3 queens? Isn't that thank you so much for that. That's the daughter, right? Daughter of oh, Karabo, there we go. Okay. Are we needing help, Karabo? I see, I think I saw a request, I think it was. Okay, thank you. So the cube root then, guys, of 125. We apply the cube root of 125. What's the cube root? Cube root of 125 is 5. Thank you, Karabo. Cube root of x cubed. You're giving me all sorts of gifts. I really appreciate them. Thank you. It's like flooding me with floods of love there. Thank you. Then the cube root of 64. It's 4. The cube root of y to the power 6. That basically says 6 divided by 3. That's y squared. Okay, very important. Then if you square 5x, you get 25x squared. 5 times 25 gives you 125. X times x squared gives you x cubed. The last term with the last term. 4 times what gives you 64, that is 16. Then y squared times y to the power what gives you y to the power 6, that's y to the power 4. The middle term, very easy. You just multiply these two terms, 5x times 4y squared. that will give you 20x y squared. The signs are already sorted. That's done and dusted. 5x plus 4y squared into 25x squared minus 20xy squared plus 16y to the power 4. Okay, guys, I think that was a factorization meal and a half, right? Factorization meal and a half. I think I will hold it right there for the factorization. Let's attend to this. Mokel, is it Karaboti? Is there something that were you specifically here for something? Is there something that you want to ask? Thanks for the gifts, by the way. Really appreciate them. Like everything. It's like it's like powerhouse, power fan stuff hitting the roof.
Hello.
Hello, Karab, how are you?
I'm good, and you?
I'm well.
Ma?
You don't sleep, do you?
Yeah, I don't sleep. I was
Why?
waiting for you.
What's up?
I just want to. Let me switch that. Okay. So I would love you to help me with the one. What do they call? Let me check this. The rations one.
You doing what? The
rations. I don't know I'm pronouncing it right.
ratio. You're doing ratio.
Yes. Yeah.
Okay. What are you doing specifically in ratios? The comparison between two quantities of the same type.
Yes. Yeah. Your live today doesn't want to switch to camera so I can show you. I don't know why.
Why?
I don't know.
Your camera is fighting.
Like the one so far on my notes, I don't know how to explain it because I don't understand anything so far.
What is there a question?
Yes.
What does it say? I'll write it down. We'll see.
Yeah, let me write it.
So I think we're transitioning from grade 10 stuff. We're going to grade 9 stuff. Ratio.
Grade 8.
Grade 8 stuff. Yeah, ratio. Ratio is also done in grade 9. That's why I'm saying grade 8 and 9. Well, grade 9 as well, because you repeat the same thing.
What's happening?
So is it like a story situation or?
Yes, there's other ones that are also like stories. I don't understand all of them, like everything, because so far I got everything wrong.
Oh, okay. So from the beginning, basically, what did you guys do with ratio? Did you simplify ratio? Did you increase and decrease a quantity using a ratio?
We started by simpling them. Yes.
So is that something that you understand, how to simplify a ratio? How to simplify a ratio?
No, I don't understand it. Yes.
Okay, then my other question that I want to ask you is, do you know how to find the highest common factor between two numbers?
No.
You don't know how to find the highest common factor between two numbers?
I think I can.
All right, let me check if you do, because if you say you do, then let's see if you do. So let's say you have a ratio which is 5:10.
Yes.
All right. Yeah. So the ratio 5:10. Okay. Yeah. So what a ratio is you are comparing two quantities. So this is your first quantity here, and then this is your second quantity here. All right.
Yes.
And we say that these quantities, they are of the same type. All right. They have to be of the same type. The same unit of measurement needs to be applied to both the quantities in order for us to qualify them as being a ratio. Okay.
Yes.
So then to sort of like then attend to this so that you can sort of like understand it a bit better. So 5 is to 10. Between 5 and 10, that would be my question to you. Do you know what the highest common factor is between 5 and 10?
Yes, isn't it 10?
No, it isn't. Okay. Remember, a highest common factor, let's just review from the earlier grades. So if I write down the number 5 and the number 10, this is like something you should have learned in grade 7, I think, grade 7, 6. So if you look at 5, if I write down the factors of 5, do you know what factors are?
No.
So that's fine. So factors are all the numbers that go into 5 without leaving a remainder. So for instance, if we start from the first natural number that we have, okay, 1. Does 1 go into 5? Karam?
Yes.
How many times?
5.
Okay, so 1 is a factor of 5. Why do we say 1 is a factor of 5? It's because 1 goes into 5 times. Okay?
Yes.
So these two numbers, 1 and 5, are factors of 5. Okay?
Yes.
Let's look at 10. 1, does 1 go into 10?
Yes.
How many times?
10.
10 times. Okay. Now let's move on to the next number. After 1, what follows immediately after 1 when you are counting?
2.
Does 2 go into 10?
Yes.
How many times?
5 times.
Okay, 5 times. There we go. So basically, you've established now from this that the factors of 10. Now think, are there any other numbers besides these 1, 2, 3, 4, 1, 2, 5, and 10 that go into 10?
Yes.
Is there any other that you can think of that goes into 10 besides these 4?
No.
That goes into 10 and does not leave a remainder?
No.
No. Okay. For instance, we can think of 3. Does 3 go into 10?
No.
Well, it does, but it's just that it goes into 10, but it leaves a remainder. So if it leaves a remainder, we don't regard it as a factor. Okay?
Yes.
Yeah, so factors are numbers that go into other numbers without leaving a remainder. Yeah, so the factors of 5, 1 and 5. Factors of 10, we have 1 that goes into 10 times. Then following that, we have 2 that goes into 10. How many times? 5 times. So these are the factors. Now, if I say to you, what is the highest common factor of 5 and 10? Look at the factors of 5, 1 and 5. Look at the factors of 10, 1, 2, 5, and 10. Which number do you see here in the factors that is common between these two, but is also the highest factor?
5.
Exactly. So 5 is the highest common factor of 5 and 10. Are we together?
Yes.
So then what you do is you go back to your ratio. Your ratio was 5 is to 10. Do you remember that?
Yes.
So step 2, you divide each quantity of your ratio by the what? By the highest common factor, which is 5. So I'm going to take this 5 divided by 5. Take the 10 divided by 5. What is 5 divided by 5? Garab.
1.
1. What is 10 divided by 5, Carol?
2.
So then that means the simplified ratio of 5 is to 10 is 1 is to 2. Okay.
Yes.
So I wanted to ask you, when you look at your examples that you have in your text, in your notes, is there an example that kind of seems a bit difficult for you as far as simplifying ratio? This is one example, okay, that I've just come up with, okay. But what you need is to know how to find the highest common factor, so that you can take that highest common factor, divide each number or each quantity in your ratio by that highest common factor, and then you can simplify the ratio to its simplest form.
Yes. I'm typing the one that I also don't understand, right?
Okay. Okay. Thank you, Torero. I need help preparing for the upcoming international maths competition. Grade 10, please. Who's this? International maths competition.
Can I do another one because it says reach the limit of typing, honey?
Sure. You can, so can't you read from, it's fine if you don't type, you can read it.
Okay. Ben gives 2 rand, Monlo gives 4 rand, and Jabu gives 6 rand to buy a packet of sweets. If there are 24 sweets in the package, how many sweets should each of them get?
Okay, so from simplifying, so this the one that I did with you was simplifying ratio. The one that you are now reading out has to do with dividing a quantity by a ratio. Okay, so just read that. So you said Ben
gives 2 rand.
Okay, 2 rand, right? Okay, then
Monlo gives 4 rand.
all right, just hold on. Mondlo 4 rand, yeah.
And Jabu gives 6 rand
Okay, Jabu gives 6 rand, yes.
to buy a package of sweets. If there are 24 sweets in the package.
So they're buying a package of sweets, right?
Yes.
Now the question is, if they are
24 sweets in the package, how many sweets should each of them get?
okay. All right, nice. Okay. So there we have the Ben with 2 rand, we have Mondo with 4 rand, and we have Jabu with 6, right? And so they want us to establish how many sweets will each person get if there are 24 seats in total, right?
Yes.
Yeah. All right. So if we think about Ben, Mondlo and Jabu. We can actually write down these amounts as 2 rand is to 4 rand is to 6 rand. Okay.
Yes.
Yeah, and then when we simplify these 2 rand is to 4 rand is to 6 rand, we can simplify the ratios, obviously, because the highest common factor between 2, 4, and 6. What is the highest common factor between 2, 4, and 6?
2.
Yeah, it is 2, right? So if I go ahead and I divide each ratio by 2, I mean each quantity by 2, then I get 1 is to 2 is to 3. Okay.
Yes.
Do you see that, Mosne?
Yes.
So then here's the thing. When we are dividing a quantity by a certain ratio, what we usually do is we add the ratio. So we consider this 2 rand as 1 part, Mondlo, this 4 rand, is 2 parts, and Jabu 6 rand represents 3 parts. So 1 part plus 2 parts plus 3 parts gives us a total of what? 1 plus 2 plus 3 gives us a total of how many parts?
6.
6 parts, right? Very good. 6 parts. All right. Then what we are then going to do is we are going to now establish that if we take the 1 part, which represents Ben's part, we say 1 over the total number of parts, which is 6, and then we multiply that by the 24 sweets that we have. Then we are going to get an idea as to how many sweets Ben was able to get with his 2 rand. So 1 over 6 times 24, right? So I'm sure you can do the maths there. 1 times 24 is 24 in the numerator. 6 times 1 in the denominator, because remember 24 can be written as 24 over 1. All right.
Yes.
The number, any number can be written as a fraction, that number over 1. Okay. So 6 times 1 is 6. What's 24 divided by 6?
24 divided by 6. Isn't it 12?
No. So 6 goes into 24 how many times? 6, 12, 18, 24. 6, 12, 18, 24. So that is?
4.
Yeah, that is 4. So we can see clearly that Ben, with his 2 rand, is going to get 4 sweets. Let's check how much Mondlo will get. Remember, okay, Mondlo, okay, we are going to say 2. All right, remember the ratio that represents, or the quantity that in the ratio that represents Mondlo's part is 2. 2 over 6. So we take the quantity 2, we divide it by the total number of parts, which is 6. Then we multiply by 24 of those sweets, so that way we can actually see how many sweets did Mondlo manage to actually receive. Okay, so we're going to do the same thing. Okay, 2 over 6 times 24 over 1. So we're going to multiply the 2 by the 24. That gives us 48. 6 times 1, that gives us 6. And what's 48 divided by 6?
8.
8, exactly. So that's 8 sweets. So that means with 4 rand, Mondlo was able to get 8 sweets. Whereas with 2 rand, Ben was able to get 4 sweets. It makes sense, right? Because, I mean, if you're paying less money, what are you expecting?
Yes.
Look at Mondlo. Okay? Are we together?
Yes.
Right. And then lastly, we want to check how much Jabu obviously paid the most money out of all of his friends, 6 rand. But we're gonna take the simplified quantity, in the ratio, which is 3. We are going to say 3 over 6. So 3 out of 6 parts times the 24 sweets. Okay.
Yes.
And I think if we say 4 plus 8 is 12, I mean, already we know what is remaining. If we have a total of 24 seeds, and we've already seen that. Sorry?
I was going to get 12 seeds.
Yeah, exactly. But let's just confirm. I mean, we should be able to get that number. 6 goes into 4, 24. 4 times. That's just another way of calculating this. 6 goes into 24 4 times. 6 goes into 6 once. 3 times 4 is definitely going to give us 12 sweets. So then when you look at your sweets in total, when you add them, it should give you back the total number of sweets that you had bought or that had been bought in that package. Because if this does not add up to those number of sweets, then it would mean that there is something that we've done wrong in our calculations. But when we find that when we add the number of sweets from having divided them, using various parts, part 1 part for Ben, 2 parts, for Mondlo, 3 parts for Jabu, then we should find that, based on the amount, it makes sense that it's 4 sweets because it's the smallest amount that was taken to buy the sweets. Mondlo paid 4 rand. It makes sense he gets 8. But then Jabu paid 6 rand. It makes sense that he got 12, the most amount of sweets out of all of his friends. So this basically then is a representation of the number of sweets based on the amounts that were paid. So what we had to do first was to actually simplify the ratio, because it was evident that 2 rand is to 4 rand is to 6 can actually be represented as a ratio, a simplified ratio. So 1 is to 2 is to 3. Then what we did is we took the ratio, we added it together. We add the ratio, step number 1. Step number 2, we take each individual quantity in the ratio, divided by the total number of parts, and then we multiply by the number of sweets so that we can get the actual number of sweets that represent Ben's share or Ben's portion or Ben's part, Mondlo's portion and part, and then lastly Jabu's portion and part. Okay.
Yes.
Yeah. So I don't know if that is clear enough for you. Dividing a quantity by a ratio. This is basically the part of ratios that we've just looked at, as opposed to what we first looked at, which was simplifying a ratio. Just simplifying a ratio.
Also, the one that I think they call it rate.
Rate.
Yes.
Rate has to do with distance, speed, and time, and also obviously there's other rates. Rate is the comparison between two quantities that are of different units or different types. Okay, so generally speaking, I don't know if you guys were exposed to the general approach to
Yes.
working out any rate type problem, but
DTS.
rate, sorry?
The DTS.
Yeah, there's DTS, but remember that you in life generally, DTS is not the only rate that exists, or let me say speed is not the only rate that exists. This is just one example out of many scenarios of rate type situations or scenarios you can have. So DST is just an example of one of the rates. Okay, because remember, speed is the rate because it literally, because of its unit, kilometers per hour. Here you are comparing directly two quantities, kilometers and hours, whereas time is a single quantity. Distance is a single quantity. Distance is in kilometers, whilst time is in hours. The combination of both is manifest with speed. Hence, we call speed a rate. And then these are just quantities, single quantities. So generally speaking, any rate, all right, featured here, you'll have quantity A and quantity B here. All right, so this is a specific example, whereas this accommodates any other general example you get exposed to. All right, because remember, sometimes you go and buy milk, you spend money. So there is a rate, for instance, that is rands per liter. All right, that's a rate. Okay, now it doesn't necessarily involve distance, speed, and time. So the question is, how do you then do calculations that don't involve distance, speed, and time? If it's not distance, speed, and time, then generally speaking, you have a rate, which obviously will feature here, then quantity A and quantity B. So just like when you say you want to calculate distance, you are going to say speed times the time, because they are next to each other. If you want to calculate speed, you say distance over time. And then when you want to calculate time, you say distance over speed. Generally speaking, if you want to calculate rate, you take quantity A, you divide it by quantity B. All right.
Yes.
And vice versa. If you want quantity B, you say quantity A divided by the rate. If you want quantity A, you say rate times quantity B. All right. So those are for specific situations. So I don't know specifically what it is you want to look at with rate. Is there something specific you want to look at when we're talking about rate?
No, not today, because so far the ones that I've learned so far to understand.
Okay.
Thank you.
Yeah. No, you're welcome. Karabo, really appreciate it, and thanks, and thank your mother as well. Thank you as well.
Pleasure.
Yeah, cheers. Yeah, I think Karabo is probably one of the only people that actually really get this thing about me going live and the gifts and stuff. Yeah, I think everybody else that comes in here really just wants me to extend a free helping hand, eh? But I really appreciated the gifts, guys, because I mean, really and truly, it's like the show came on the road the minute these individuals landed. So thank you so much for that. With just 15 minutes, I think, left, because I'm going to be sleeping at 12, guys. Is there anything else that you guys wanted to maybe look at before I go? Can you do algebra when you're done with raising? Can you do algebra? What algebra? What part? We've been doing algebra. What do you want now? Who's this person? Angel M. Simplifying trinomials. What do you mean by simplifying trinomials? Do you know what you're asking me? Good vibes. It's me. Simplifying trinomials. Do you know what you are asking when you're saying simplifying trinomials? Give me an example of what you mean. You see, I just extended a request now to you. I'm a guest request. Come, tell me what you mean. Okay, we'll have these people come up, Angel M, because you will thank raising 3 queens. You'll thank Karabo. I don't accept requests unless people actually gift, so, but it's fine. Angel M will Karabo has catered for you guys the last 13 minutes. Yes, Angel M, how can we be of help?
Can we do adding and subtracting like term?
Adding and subtracting like terms.
Yes.
Okay, so very quickly, okay, adding and subtracting like terms. If you have like terms, Angel M, 3x squared plus 5x squared. Remember, like terms, what are like terms? Like terms are
A term with the same variable and same power.
exactly, there we go. So what do you want then from me? Because you know what you're talking about. You understand the concept. It's a matter of applying the concept consistently in questions that have such a situation, and that's it. You know you can add like terms, you cannot add unlike terms. And that's that, really. So what do you do when you add or subtract like terms? You keep the variable and its power as it is because it is the same uniform, and then you add or subtract the coefficients 3 and 5. So obviously in this case you'd have 8x squared, you know, and every single case where you are confronted with an expression and it does exhibit likeness, then you add those like terms by keeping the variable with its exponent, whatever that combination is, and then you add and subtract the coefficients. I think you would just have to consistently apply the method over and over again when confronted with such. What grade are you in, Angel, now?
Oh, I'm in grade 9.
Oh, you're in grade 9. No, you are in a nice grade. I know, it's fine. No, then you must practice. You know the concept. It's a matter of practicing. Apply so that you can be the master. If you are not the master already, you seem like you're the master already.
Oh,
Yeah, I think Angel M, you're fine. You're good. You're good. You're good. It's a matter of ironing out. You just need to apply. Okay, guys, so it's just 10 minutes to go because I definitely have to sleep at 12. Okay, cannot stay beyond the 12-minute mark. It will be too much. Too much. Can you do all? Yeah. Okay. Can we do simplifying? What does this person is saying simplifying trinomials? What do you mean? You see, you need to be specific when you ask something, guys. It doesn't help being non-specific. Be specific, direct, straight to the point. Get to the heart of the matter. Don't leave me. Don't ask and be vague. Being vague, it doesn't help. Right? You must know what you want to ask, you know. So for instance, are you able to help Karabo very quickly and you know, and you can see she knew exactly what she wanted to ask, and yeah, she came bearing gifts too. So I was able to get straight to the point and help out where the need was. Okay, yeah. What a day it's been, eh? What a day it's been. You let me like you've been here the whole time. Yeah, ulali when. Ulali pal. Okay, you are sleeping, and the phone is phoning on its own. Phoning and folding. Okay, let's see, is there any other? Yeah, guys, I find these questions very interesting. I think since we are here, okay, maybe I can just conclude with some interesting questions here. Look at this. Look at this question. If x minus 1 over x is equal to 7, determine the value of x squared plus 1 over x squared. And number 2, the value of x cubed minus 1 over x cubed. If x minus 1 over x is equal to 7, determine the value of x squared plus 1 over x squared. Very interesting, right? So let's check this out very quickly. Let's see if you guys can follow. So they're saying if x minus 1 over x is equal to 7, what do we need to do? Determine the what? The value of who? Of x squared plus 1 over x squared. So x minus 1 over x is equal to 7. They're saying if that is the case, if this is true, determine the value of that. So let's take this x minus 1 over x is equal to 7. Okay, and let's put a bracket around x minus 1 over x and put a square here. But remember with equations, okay, so what I'm doing is I am squaring both sides. What I do on the left, I do on the right. So x minus 1 over x, the whole thing squared, means x minus 1 over x into x minus 1 over x. Let's not forget that, which is equal to what? What's 7 squared? 49. Are we together so far? Then we say x times x, which is x squared. X times negative 1 over x, x times negative 1 over x. This x is in the numerator, this x is in the denominator. X times 1 is negative x. Then this is a 1 in the denominator. 1 times x is x. So we have negative x over x, okay, which I'm going to simplify. Then we take this negative 1 over x. This x is in the denominator, this x is in the numerator. So 1 times x is negative x over 1. X times 1 is x as well in the denominator. Then we multiply this with that. Be careful, guys, when you're multiplying 1 over x with x, because the tendency is that some people think this x is in the denominator and this x is also in the denominator. It's not the case. This x here, which is standing alone, is an x over 1 in other words. Okay. Then we take this 1 over x times negative 1 over x times negative 1 over x. And negative times a negative is a positive. 1 times 1 is 1. And then this x and this x are both in the denominator. X times x is x squared, which is equal to 49. Okay, so far so good. Hope we are good. Now x squared. What's a negative x divided by x? Something divided by itself gives us negative 1. Likewise here we get another negative 1 plus 1 over x squared is equal to 49. Now remember, we want the value of x squared plus 1 over x squared. So what we are going to do is we are going to add these like terms. And then we're going to take this negative 2 and transpose it so that we leave x squared plus 1 over x squared on its own on the left. Take the negative 2, transpose it. That becomes 49 plus 2. Okay. Then this is x squared plus 1 over x squared, which is equal to, what's 49 plus 2? It is 51. This here, guys, gives me the value of x squared plus 1 over x squared. Determine the value of x squared plus 1 over x squared. Okay, if x minus 1 over x is equal to 7. So I took the x minus 1 over x, which is equal to 7, squared both sides, expanded it, multiplied it out, added and subtracted the like terms, transposed the negative 1, which is negative 2, over to the other side, became plus 2, added the 49 to the 2, got 51. And then the expression of x squared plus 1 over x squared gives me a specific value of 51. So what is the value of x squared plus 1 over x squared? It is equal to 51. Okay, very interesting question. If x minus 1 over x is equal to 7, determine the value of x squared plus 1 over x squared. And all I did is I took this equation, squared it both sides, multiplied it out, FOILed, and then transposed what could be transposed, which is a numerical value, and I was able to get the specific value of x squared plus 1 over x squared, which is equal to 51. Okay, not too shabby. Okay, I think there's someone who typed, and I'll just conclude on that. What must you do if the question says the following? If the question says the following, 6x squared plus 5x plus 3 minus 7x squared plus 3x plus 5. What must you do if the question says such? Well, you have 6x squared plus 5x plus 3. All you do is you take this negative sign, because you see this 6x squared plus 5x plus 3. The negative sign needs to be distributed inside the bracket. So you are going to multiply that negative sign inside that bracket. Negative times a positive, negative 7x squared. Negative times a positive, negative 3x. And then a negative times a positive, negative 5. Then what you do is you are going to add and subtract the like terms. You bring the like terms close to each other. So the 6x squared needs to be, who needs to be brought a little bit closer? Negative 7x squared. The plus 5x, who needs to be brought closer? Negative 3x. The plus 3, who needs to be brought closer? The minus 5. Then what do? You look at those like terms. Remember, those like terms, you keep the variable with its exponent, and you say 6 minus 7, that's negative 1. 5x minus 3x, you keep the variable x, you subtract the coefficients. 5 minus 3, that gives you positive 2. 3 minus 5, 3 minus 5 gives you negative 2. And that's that. You cannot add or subtract unlike terms, because this is x squared, this is an x term, this is a constant term. So you leave that question like that. You can't do anything else besides that. You need to interpret that, Angel M. You need to interpret that. If it says subtract the following trinomial from, okay, it's the same thing like saying subtract. If I say to subtract 8 from 3, what does this mean? It means that if you are going to subtract 8 from 3, who do you start writing? You write 3, and then you subtract the 8 from the 3. So this is 3 minus 8. What's 3 minus 8? It's negative 5. So the order in which you place what you are writing, you need to interpret the language in English so that you represent what the English language actually means in mathematics. So here, what are they saying? Subtract the following polynomial, negative 2x squared plus 7 plus 3 from. So who's going to start? If they are saying from 3, from 7x to the power. So you start with 7x to the power 4 minus 4x plus 5. I feel like you have forgotten something here. So you will subtract what? What are you subtracting? You are subtracting negative 2x squared plus 7x plus 3. You close the bracket. So this would be 7x squared minus 4x plus 5 minus 2x squared plus 7x plus 3. Okay, so you say minus. Okay, So then you write down the 7x squared minus 4x plus 5. I'm going to leave after this. Negative times a negative is positive. Negative times a positive, so it will be positive 2x squared minus 7x. Then a negative times a positive is a negative 3. Then what you do is you bring the like terms close to each other. 7x squared plus 2x squared minus 4x minus 7x plus 5 minus 3. Okay, and after that you get the answer 9x squared minus 11x plus 2. That's done. Okay, so yeah, if they say add, same thing. Okay, you write down the expression, you write the addition sign, and you put it in brackets, and then you distribute that positive sign first. You remove the bracket by distributing the positive sign. Positive sign doesn't affect any of the terms, but it's always the negative sign. If there's subtraction between two terms, right, put the terms that follow in brackets so that the negative sign can affect those signs inside. See, negative times a negative is a positive. Negative times a positive is a negative. A negative times a positive is a negative. Okay. All right, guys, let me love and leave you. Good night to all of you. Thank you so much for joining in the lesson. I know it was quite long. There was a lot in here, like from factorization, literally from factorization, looking at the golden rule, to different types of questions in factorization, okay, to trinomial, all right, to difference of two squares, to some complex questions there and there, to Garabo asking about ratio, dividing a quantity in a given ratio and rate, and now me having to actually conclude, and then also Angel M asking about subtraction of algebraic expressions and so forth. Guys, I need to love and leave you. Have a good one, and yeah, see you again when I see you. And thank you for the gifts again, Karabo. Thank you so much. I really appreciate that. Also, please do thank your mother as well, Tswarelo, for always just being supportive and being great sports when you guys do rock up here. It means the world. Thanks. Okay.